Okay, all right, chaliye. So let's start with the session. First question is, 1 mole of an ideal gas expands with temperature according to the relation V is equal to K times T to the power 2 by 3. The work done when the temperature changes by 30 degrees Celsius is, delta T is 30 degrees Celsius. You have to find the work done when the temperature changes by 30 degrees Celsius over here, right? So how do we calculate work done? It is integration of P dV, right? And for 1 mole of an ideal gas, PV is equal to RT. So if you differentiate this equation, you will get dV is equal to K times differentiation of T to the power 2 by 3, which is 2 by 3 times T to the power 2 by 3 minus 1, which is 2K by 3 times T to the power minus 1 by 3 dt. Right? All right, chaliye. Okay. All right, sound aa gaya. So let's try this question now. ठीक है, चलिए. So we have dV value this much and pressure will be RT upon V. So when you put pressure as RT upon V, but V is K times T to the power 2 by 3. So it will be RT divided by K times T to the power 2 by 3, which is R by K, times T to the power 1 minus T to the power 2 by 3 is T to the power 1 by 3, right? So we have pressure value in terms of temperature, we have dV value in terms of temperature. Let's put it here in this formula. So it will be integration P as R by K times T to the power 1 by 3 into dV, which is 2K by 3 times T to the power minus 1 by 3 dt. T to the power plus 1 by 3 into T to the power minus 1 by 3 will be nothing, T to the power 0. So it will be R by K outside into 2K by 3 outside, integration of dt. K cancel, so integration of dt will be T only. So R 2R by 3 times integration of dt will be delta T, where change in temperature is equal to 30 degrees Celsius, right? So it will be 2R by 3 times 30 degrees Celsius, which is nothing but 10. So it will be 20R. This is the work done in this process, which is option B. Alright, so whenever you have work done, please apply this formula to get the answer. And for ideal gas, use PV is equal to nRT for any conversion. Right, this will give you the answer. Chaliye, let's move on to the next one. The decreasing order of wavelength of infrared, microwave, ultraviolet and gamma rays is. So you have to arrange these 4 waves, infra, micro, ultra and gamma, in decreasing order of their wavelength. Right, so try this one, come on guys, try this one. Option B, option B. Okay, this is for the previous question. Chaliye, option B, okay. All right. So gamma rays have the minimum wavelength. So this is not possible. This is possible. This is not possible. Out of this 4, microwave has the maximum. So this is not possible. After micro, we have infra, ultra and then gamma. So correct answer is option D, right? Correct answer is option D. So in EM waves, you should know the frequency and wavelength range of the electromagnetic spectrum. Fine? Chaliye. Next is this one. A wave traveling in the positive x direction having maximum displacement along y direction as 1 meter. Maximum displacement is nothing but the amplitude. Wavelength is 2 pi meter and frequency is 1 upon pi hertz. Then what is the equation of that wave? What is the equation of that wave? Right? So How do we write the equation of a traveling wave traveling in positive x direction? Y is equal to a sine kx minus omega t. Amplitude is given as 1, k is 2 pi by lambda, which is 2 pi by lambda is 2 pi, so it is 1, and omega is 2 pi into frequency, so it is 2 pi into 1 by pi, which is 2. Right, so you just have to put k and omega in this equation to get the answer. Y is equal to a is 1 sine k is 1 minus omega is 2t. So it is sine x minus 2t, which is nothing but option C over here. Well done guys, well done. Chaliye. Alright, let's move on to the next one. The phase difference between acceleration and velocity of a particle executing SHM is. What is the phase difference between velocity and acceleration? Bachcho, what is the phase difference between velocity and acceleration in SHM? Come on guys. Phase difference between velocity and acceleration. Option A, well done Rupa. So it is 90 degree, well done. Between displacement and velocity, 90 degree. Between velocity and acceleration, 90 degree. And between displacement and acceleration, it is 180 degree. You should remember all these three things. Fine? Yes, beta. Well done. So correct answer is option A. Next is this one. A step-up transformer is used to. Option A, increase the current and increase the voltage. Option B, decrease the current and increase the voltage. Option C, increase the current and decrease the voltage. Option D, decrease the current and decrease the voltage. Try this one. Again, this is conceptual question, everyone. Why do we use step-up transformer? We use this one to increase the voltage and decrease the current, right? For an ideal transformer, N1 upon N2 is equal to V1 upon V2 is equal to I2 upon I1. So if you are increasing the voltage, current will decrease, right? So correct answer is option B, decrease the current and increase the voltage over here. Well done beta, well done everyone. Chali, let's move on to the next one. Two charges are at a d distance apart. There are two charges and these are d distance apart. If a copper plate of thickness d by 2, a copper plate of thickness d by 2 is placed between them, the effective force will be. What is the effective force? Try this one everyone. Two charges are at a d distance apart. If a copper plate of thickness d by 2 is placed between them, the effective force will be. Option C, well done, well done. Anyone else? Anyone else? We have the relative permittivity of conductor is infinite, right? So, if epsilon r is infinite, when it will go into the denominator, the total force will be 0. The total force will be 0, right? So, effective distance with some plate in between is r minus x plus x root k. This is what we have as r effective. Fine. So, x is nothing but the thickness of the plate. So, total separation is d, thickness is d by 2 plus d by 2, under root k is under root infinite. So, basically this complete is infinite. So, if r effective is infinite, it will go into denominator and it will make the entire force 0. So, correct answer is option C over here. Alright, well done beta, well done. Chaliye, let's move on to this one. A soap bubble of radius r is blown up from a bubble of radius 2r under isothermal conditions. If T is the surface tension of bubble, the energy spent in the blowing is. What is the energy spent? So for soap bubble, how much work or initial energy we can find? Initial energy it has radius 2r, so it will be 2 times surface tension into surface area, which is 4 pi into 2r whole square. So it will be 1632 times pi p r square. Final energy will be, it will be 2 times surface tension into final surface area of radius r. Okay, so it will be 4 pi r square, right? So in this case, we have energy difference as 8t pi r square, and this is 32 pi t r square. So 32 pi t r square minus 80 pi t r square will be 24 pi t r square, which is option D, not option B beta. Alright, chaliye, well done guys, well done. Now next is the de Broglie wavelength of a particle moving with velocity 2.25 into 10 power 8 meter per second is equal to the wavelength of photon. The de Broglie wavelength of the particle is equal to de Broglie wavelength of the photon, just wavelength of the photon. The ratio of kinetic energy of the particle to the energy of photon is, you have to find the ratio of kinetic energy of the particle to the energy of the photon. Please try this one everyone, please try this one. Velocity of the particle is given, option C, alright. So we have de Broglie wavelength of the particle as h upon mv. So from this one, mass of the particle as h upon lambda v. Now you can find the kinetic energy of the particle as half mv square, which is half m is h upon lambda v into v square. Vv cancel, so it is h upon hv divided by 2 lambda. Right, this is the kinetic energy of the particle in terms of lambda and v. Now energy of the photon is hc divided by lambda. Right, we have to find the ratio of kinetic energy of the particle to that of the photon. So it will be hv divided by 2 lambda divided by hc divided by lambda. H lambda cancel, so it is v upon 2c. V is 2.25 into 10 power 8 times 2c is 3 into 10 power 8. Cancel, so we have 2.25, 2 into 3, remove this points, so it is 4 and this will be 9. So this will be 3. So it is 3 upon 8. 3 is to 8 is the correct answer, which is option B. Alright, so that is how it can be done. This is from modern physics. Let's move on to the next one. A fish in water, refractive index of water is n, and fish is over here. Looks at a bird in air vertically above. If x is the depth of the fish over here and y is the height of the bird, y is the height of the bird. The distance of bird as estimated by the fish is, what is the distance of bird as estimated by the fish? Try this one, try this one. Try this one everyone. What should be the correct answer? Here you have to apply the concept of apparent height. The observer is in rarer medium. The object is in, observer is in denser medium. This is water, and object is in rarer medium. Option B, well done. So object will appear slightly above its actual position and the apparent height will be n times y. Right, it is n times y. Refractive index of the denser divided by refractive index of the rarer medium is n into y. Y is the actual height. So the distance of this bird estimated by the fish will be this much length, which is x plus ny, which is x plus ny, which is option D. Alright. Next is this one. We have the following diagram indicated the energy levels of a certain atom when the system moves from 4e to E level, the photon of wavelength lambda 1 is emitted. The wavelength of the photon produced during the transition from 7e by 3 to E level is lambda 2. Then what is the ratio of lambda 1 to lambda 2? So delta E, the difference in the energy level, should be Hc divided by lambda, right? Whatever energy difference is there, that energy difference will appear in the form of energy of photon, which is Hc divided by lambda, right? So in the first case, the energy difference is 4e minus E, 3e, it should be Hc divided by lambda 1, and in the second case, the energy difference 7e by 3 minus E is 4e by 3, and it should be Hc divided by lambda 2. So just divide 3e with this one. So Hc cancel, E cancel. So 4 upon 9 is lambda 1 divided by lambda 2. So lambda 1 upon lambda 2 is nothing but 4:9, which is option B. Option B beta, right? Alright. I hope it is clear now. Next is this one. Same force acts on two bodies of different masses, 3 kg and 5 kg at rest. The ratio of times required to acquire the same final velocity is. Chaliye, try this one everyone. This is from laws of motion. You have to find the ratio of the time required to acquire the same final velocity. Chaliye. Vanama Vandana, Rupa, Amritandu, Karthik, Sai. Try this one, try this one. Initial velocity of both these bodies is 0, right? Both are at rest. M1 is given as 3 kg and M2 is given as 5 kg. Now we are applying the same force beta, right? We are applying the same force over here. So acceleration of the first body is F upon M1, which is F upon 3. Acceleration of second body is F upon M2, which is F upon 5, right? We have A1 and A2. Now, initial velocity for both the particles is 0. Velocity after time t will be V is equal to U plus AT, U is 0, so it will be A1 T1. And velocity after time t2 for this one is V2 is equal to A2 T2. Now it is given that they should have the same final velocity at a t1 and t2 time respectively. That means A1 T1 should be A2 T2. So from this one, A1 will be F by 3 times T1 and A2 is F by 5 times T2, FF cancel. So we have T1 upon T2 as 3 by 5. So this is the ratio of time required to acquire the same final velocity for both the particles, 3:5, which is option D. Alright, let's move on to this one. Two identical circular loops of metal wire are lying on the table without touching each other like this. Loop A carries a current which increases with time in response in loop B. The current remains stationary. It is the loop B remains stationary. It is attracted by A, repelled by A, or rotated about A. What should be the correct answer? Right, so this is based on electromagnetic induction. Mutual induction hoga. So in this one, if you assume the direction of current like this, in this region the magnetic field is out of the plane. this out of the magnetic field is increasing with time. So flux which is coming out of this loop is increasing with time. So in order to oppose its increase in flux, it should generate the magnetic field in the opposite direction, like this. So in order to have the magnetic field in opposite direction, current should flow like this. This is the induced current direction. So you can see that these currents are anti-parallel. So when the currents are anti-parallel over here, this two will repel each other, right? So it will be repelled by A. It will be repelled by A. So correct answer is option C. Next is this one. Potential energy of a particle in the force field is A upon r square minus B upon r. Where A and B are positive constants, r is the distance of particle from the center of field. For stable equilibrium, the distance of the particle is, what is the distance of the particle for stable equilibrium? Try this one. What is the condition of equilibrium? du upon dr should be 0. Right? So you can write u as A times r to the power minus 2 minus b times r to the power minus 1. Now differentiate u with respect to r. So it will be A times r to the power minus 2 differentiation is minus 2 times r to the power minus 2 minus 1 minus b times differentiation of r to the power minus 1 is minus 1 times r to the power minus 1 minus 1. So it will be minus 2a times r to the power minus 3 plus b times r to the power minus 2. So you can write it as minus 2a divided by r cube plus b divided by r square. 1 upon r squared common, so it is minus 2a divided by r plus b, and it should be 0. So either 1 upon r square is 0, that means r is infinity, right? Or this term should be 0. So minus 2a upon r plus b is 0, that means b is equal to 2a upon r. So r will be 2a by b, which is option B. Option B is the correct answer. In order to cross check this one, you can double differentiate du upon dr and then put the value of r to confirm the location of stable equilibrium. Chaliye, next is this one. An alternating voltage is equal to 200 root 2 sine 100 t is connected to 1 microfarad capacitor through an AC ammeter. The reading of ammeter will be, well done beta, you have to find the reading of ammeter. So you can compare this with the standard equation. E naught is 200 root 2 and omega is 100. Okay? XC, we are connecting it through the capacitor. So XC, capacitive reactance will be 1 upon omega C, which is 1 upon 100. C is 1 microfarad, which is 10 to the power minus 6 farad. Right? So it is 10 to the power minus 6. So it will be 10 to the power 4 ohms. That is the XC value. We have to find the reading of ammeter. So reading of ammeter is RMS value of the alternating current, not the peak value, not the average value, nor the instantaneous value, but it is RMS value of the alternating current, right? So for finding RMS, you need IRMS, you need ERMS. So ERMS is E naught upon root 2, which is 200 root 2 divided by root 2. So it will be 200 volt. This is ERMS, right? Now IRMS will be ERMS divided by XC. So ERMS is 200, XC is 10 to the power 4, or you can write it as 20 milliampere. So correct answer is option B. Option B was correct, Vanama. You retracted your answer, but it was correct. Well done, beta. Chaliye. Next is this one. In Young's double slit experiment, intensity at a point is 1/4 of the maximum intensity. What is the angular position of this point? You have to find the angular position theta of this point. So in this case, I is I max times cos square phi by 2, where phi is the phase difference. I is I by 4 or I max by 4, and it is time I max times cos square phi by 2. I max cancel, so cos square phi by 2 will be 1 by 4. So cos phi by 2 is 1 by 2. Cos is 1 by 2 when the angle is 60 degree, which is pi by 3. So phi by 2 should be pi by 3. So phi will be 2 pi by 3. This is the phase difference. Now using phase difference, find the path difference. So phase difference is equal to 2 pi by lambda times the path difference, right? So path difference will be lambda upon 2 pi times the phase difference, which is 2 pi by 3. 2 pi cancel, so path difference is lambda by 3. Now we know that path difference in YDSC is d sine theta, where theta is the angular position of this point, right? Alright, chaliye, hello beta. So delta x is lambda by 3 and it should be d sine theta. So from this one we have sine theta as lambda upon 3d. So theta is sine inverse lambda upon 3d, which is option C. Well done guys, well done. Chaliye. Alright, let's move on to the next one. We have assertion reason types question now. So assertion is the velocity increases when the water flowing in broader pipe enters into narrow pipe. Yes, that is true. When you have when you are watering your plants and then suddenly you compress the opening of the pipe, the water comes out with higher velocity, right? So over here, the velocity of the water increases when water flowing in broader pipe enters into the narrow pipe. Yes, it is true. Why it is true? For that we have reason. According to the equation of continuity, product of area and velocity is constant. A into V is constant, which is also true. So if AV is constant, velocity is inversely proportional to area. If area is less, velocity will be more. That is why water flows with higher velocity in narrow pipe than the broader pipe, right? So that is why assertion and reason both are true, and reason is the correct explanation of assertion. So correct answer is option A. Option A is correct. Well done guys, well done. Good job everyone. Chaliye, let's move on to this one. The combination of gates shown below produces. So this combination of 4 gates is equivalent to what? AND, XOR, NOR and NAND. Alright. So this is NOT gate. This is another NOT gate. This is your NOR gate and this is another NOT gate. So if A is passing through NOT, it will become A bar, and B is passing through NOT, it will become B bar. Now A bar and B bar are the inputs to this NOR gate. Option D, alright. A bar and B bar are the inputs to this NOR gate. So for NOR gate, output will be A bar plus B bar whole bar. So according to the De Morgan's theorem, if you take A bar with plus of B bar whole bar, it will be A into B only. So basically the output of this NOR gate is A into B. Now this output is input to this final NOT gate. So NOT gate will reverse everything. So whatever input you are providing to this NOT gate, it will come out with bar. So Y will be A into B whole bar. So this is equivalent to what? NAND gate. This is nothing but the final output of NAND gate. So correct answer is option D over here. Chaliye. Next is this one. The moment of inertia of a thin rod of mass m and length L about an axis perpendicular to the rod at a distance L by 4 from the end is. So let's say this is the axis of rotation and we have to find moment of inertia about this axis, which is at a distance of L by 4 from the end. So from center of mass, it is also L by 4 because center of mass is exactly at the center. So this total distance will be L by 2. So L by 4 and L by 4 will make L by 2 over here, right? Chaliye. Now we have to find the moment of inertia about this axis, right? So first of all, we have to find what is the moment of inertia about the center of mass. So this is the axis which is passing through the center of mass, and moment of inertia about center of mass is ml square by 12. Now we have to apply parallel axis theorem because both of these axes are parallel. Option C, well done. So over here we have parallel axis theorem as moment of inertia about this axis is ICM plus md square. What is ICM? ml square by 12 plus m d square. D is the separation between these two parallel axes, which is L by 4 whole square. So it is ml square by 12 plus ml square by 16. 48 LCM. So this is 4 ml square plus 3 ml square. So it will be 7 ml square divided by 48. So correct answer is option D. Well done guys, well done. Option D is the correct answer. Chaliye, let's move on to the next one. A magnetic needle is kept in non-uniform magnetic field experiences a force and a torque, a force but not torque, a torque but not a force, neither torque nor force. Chaliye, क्या होगा? Hello everyone. All right. This is non-uniform magnetic field. So magnetic needle will experience both force as well as torque, right? It can experience a force as well as a torque. So correct answer is option A. Let's try this one. A wire has a mass. This you have to tell me. This is from units and measurement. 0.3 plus minus 0.003 gram. Radius as 0.5 plus minus 0.005 millimeter. And length as 6 plus minus 0.06 centimeter. The maximum percentage of error in its density is, you have to find the maximum percentage of error in its density, in the density of wire. Try this one. This you have to tell me everyone. This is very simple. This is from the units of units and measurement. Density is mass upon volume. Volume can be written as area of cross section into length. Area of cross section is circular because radius is given. So it is m upon pi r square into L. Okay, this is the density in terms of area, radius, mass and length. Now you guys try this one. What is the maximum percentage error in the density? 1%, 2%, 3%, 4%. Chaliye. क्या होगा बच्चों? What should be the correct answer? Find the percentage errors in the measurement of M, R and L first. It is M plus minus delta M. So percentage error in the measurement of M will be delta M upon M into 100%, right? So it will be 0.003 divided by 0.3 into 100%. So it will be 1% beta. 1% is the percentage error in the measurement of M. Also find the percentage error in the measurement of R, which is 0.005 divided by 0.5 into 100%. So it will be 1%. Again, percentage error in the measurement of length. Option A, well done, is 0.06 divided by 6 into 100%, which is again 1%. So M, R and L, all three quantities are having 1% of percentage error in the measurement. Now this is the expression of density, M upon pi R square into L. So percentage error in density is 1 times percentage error in mass plus, it is R square, right? So it is 2 times the percentage error in radius plus L to the power 1. So it is 1 times the percentage error in length. So it will be 1 plus 2 plus 1, which is 4%. So correct answer is option D. Option D is the correct answer. Fine. Chaliye. So we have one ultimate NEET long-term course for you, Vaidya 2025 batch. And if you want to be part of this ultimate NEET long-term course, you can fill the Google form and its link is given in the description box over here. In this batch, we'll focus more on physics and chemistry. We'll focus on more on the important concepts. We'll be solving a lot of questions along with multiple grand test and part test for you guys. Okay, so if you want to be part of this ultimate NEET long-term course, fill the Google form immediately and our team will connect with you. So that is it for today's session, everyone. Thank you so much, guys. Take care, bachcho. I'll see you tomorrow at the same time with few more amazing questions. Take care, everyone. Bye bye, bachcho. All the best. Bye.